The CPU, or central processing unit, is like the brain of your computer. It handles everything your computer does, from opening a file to playing a game. Without a CPU, your computer would just be a box of wires and circuits. The CPU is a small chip located on the motherboard, which is like the main circuit board of your computer. Don't let its size fool you. This tiny chip is responsible for executing all the instructions that make your computer work. From simple calculations to complex gaming graphics, the CPU is involved in every task. Understanding its components provides insight into how computers process information and execute tasks. Inside the CPU, you'll find the Arithmetic Logic Unit, or ALU. Think of the ALU as a math whiz. It performs basic arithmetic operations like addition, subtraction, multiplication, and division. But that's not all. The ALU also handles logical operations, such as comparing two numbers to see if they are equal, or if one is greater than the other. It's like the ALU is constantly asking, is this bigger, or are these the same? Every time you open a program, type a letter, or click the mouse, the ALU is hard at work, crunching numbers and making comparisons to make sure everything happens correctly. Imagine you're working on a puzzle and you keep the pieces you need most often close at hand. That's what cache memory is like for the CPU. It's a small, super-fast memory that stores frequently used data and instructions. When the CPU needs to access certain data, it first checks the cache. If the data is there, it can be retrieved much faster than if it had to go all the way to the main memory or RAM. This is like having your favorite book on your bedside table instead of having to go to the library every time you want to read it. Cache memory helps the CPU work more efficiently and speeds up your computer's overall performance. Modern CPUs often have multiple cores. A core is like a mini CPU within the main CPU. Each core can process instructions independently, allowing the CPU to handle multiple tasks simultaneously. Think of it like having multiple chefs in a kitchen. Each chef can work on a different dish at the same time, which means more dishes get prepared faster. Similarly, multiple cores allow your computer to run several programs at once without slowing down. More cores generally mean faster processing and smoother multitasking. This is especially important for demanding tasks like video editing, gaming, or running complex software.